we're going. Do you know where you send extra belly buttons? To the Naval Reserve. Okay, that's enough jokes.
Can you explain that one for us?
A naval, that's your belly button is called your navel, right? Did you know that? And so you send extra ones to the navel. You didn't know that? Oh, that's another.
Well, I knew it's called naval. I just
Okay. Speaking about belly buttons, I got a new car. What? Yeah, it's an Audi. Okay.
Are you saving these jokes? Really? You got an Audi?
No, I can't afford an Audi. I might now because they're running into the same problems as Volkswagens have. Did you know that the diesels, like the Volkswagen, the diesel Volkswagens, they're getting now that it's going on to the Audis as well. Okay, so what was I going to do? This is 6-2. This is Law of Cosines. Law of Cosines. And Law of Cosines is used for solving oblique. I write neater on the board. Oblique triangles. Oblique, and oblique means non-right triangles. When given a side, or a side, angle, side. So with the law of sines, you can solve triangles if you have an angle, side, angle, or angle, angle, side, or even side, angle, ambiguous case. But for law of cosines, you use it when you have side, side, angle, side, or side, side. Side, angle, side, or side, side. Okay? And law of cosines says, aha!
Hey, I finished this up.
Okay.
Yeah.
Okay, and law of cosines says this: if you have some triangle, let's just try a triangle, three-hand shape. We already went over them. Okay, where say this is side A. I just started. This is B. This is C. This is little c, this is little a, this is little b over here. It's kind of like c squared equals a squared plus b squared. What's that? That's the Pythagorean theorem. However, with the law of cosines, you have this part, minus 2ab cosine c. Okay? Now you could use and I don't remember, there's actually like 3 different formulas. B squared, but they're really the same formula. B squared is equal to a squared plus c squared minus 2ac cosine, guess what? B, right? And a squared, you could probably figure out what that formula is going to be. What is it? What goes here?
A squared.
B squared plus c squared, right? Minus 2bc cosine of a. So the important thing to realize is that so this is the angle, right? So this angle here and this side here are opposite from each other, right? So here's angle C, here's side C. These two sides are the sides of that angle. So if I'm looking at this formula, here's side C opposite angle C, and A and B are the two sides on the sides of that angle. So, think about this. What's the cosine of 90 degrees? What's the cosine of 90 degrees? 0, right? So if I were to plug in 90 degrees in for angle C, so say this angle is 90 degrees, what would I have here? You just have c squared equals a squared plus b squared, which is the Pythagorean theorem, right? And so if this angle is less than 90 degrees, and you take the cosine of it, you're going to be subtracting something. If this angle is bigger than 90 degrees, what's the cosine of an angle bigger than 90 degrees? Negative or positive? Negative, right? So when I subtract a negative, I'm actually adding something to this side of the equation, right? So in that case, c squared is bigger than a squared plus b squared. So this angle is bigger than 90 degrees. You're going to be adding something to a squared plus b squared. And if this angle is less than 90 degrees, you're going to be subtracting something. See the way to think about that? Okay? So it kind of makes sense. And then, so let's do it. So solve the triangle. Solve the triangle. Put your phone away. Yes, you. I'm not going to mention any names because we're recording now. You know, I wouldn't want me to send this video to your parents and say, put your, Sean. No, I'm just. Solve the triangle given. Where's my numbers here? Given. A is 5. A equals 5. B equals 8. And C equals 7. Okay? So you could pretend that this is your triangle right here. This is a side, side, side. So, I forgot something. Okay? You can solve these if you solve these for C, B, and A. So I never really taught this formula because it's kind of one more thing to memorize. But angle C is equal to the inverse cosine of A squared. I'm going to take A squared plus B squared. If you did some algebra, you could figure this out. A squared plus B squared minus C squared divided by 2AB. And angle A is equal to the inverse cosine of B squared plus C squared, B squared plus C squared minus A squared over, this should be big parentheses like that, over 2BC, and angle B is equal to the inverse cosine of A squared plus C squared minus B squared over, big parentheses, over 2AC. Okay? So you could do a little algebra. It's real quick to change this into that. But basically, here's the angle. These are the two sides around the angle. Then you subtract the opposite side squared and divide by these two sides again. So if you recognize it once, you don't have to memorize 3 formulas. All you have to know is how it works. So in this case, solve the triangle. So let's find angle A. Okay? So angle A is going to be equal to, let's see, angle A is going to be equal to the inverse cosine of B squared, which is, what's B squared? 68 squared, 8 squared, plus C squared, which is 7 squared, 49, minus A squared minus 5 squared divided by 2 times 8 times 7, right? 2 times 8 times 7. And make sure you're in degree mode, and if you plugged and chugged that into your calculator, be careful. Do not call this -5 quantity squared. It's 5 squared and then you subtract. Yes, Ben?
Would these formulas work with angle side? You still have the
Angle side. No, because you angle side. Angle side. No, angle side. Because you don't have two sides surrounding the angle, right? You have to have the two sides that are on either.
y.
Why?
Because it seemed like you could put it into the formula, right?
No, you couldn't, because you'd have C. You wouldn't have B, right? If you need A, B, and it won't work.
But you'd have, so if you had like C, A, and C.
Because you need to have A and B. If you're trying to solve for, say you know C and A, and say you know angle C, and you know side A and side C,
Yeah.
right? That's not enough. You need to know side B as well. I guess you could solve it for side B.
Yeah.
Yeah,
Or
you
just
could.
use some.
Yeah, I would just use a lot of signs because it's easier. Okay, but also you'd have ambiguous case, and I'm not sure. I'll have to try that and see if it works. But I think,
Oh, maybe it doesn't because the ambiguous.
yeah, it wouldn't work because you don't know whether this is, because with cosine, depending on the size of this angle, that could be, I guess if you knew this angle, you could do it. Yeah, I think so. But I would just use cosine. Okay, and anyway, it'd be kind of tricky to solve for. And so in any case, when you plug this in, you get that this angle is about, did anyone do it? Anyone do that? You should get that this angle here is about 38.2 degrees, okay? So angle A is approximately 38.2. And if I know that this is 5, and B is 8, and C is 7, okay? Now how could I find angle B?
Law of Cosines.
You could, but again, you can't, okay? The reason you can't use law of sines is because you still have an ambiguous case, right? Because you just have an angle and a side, and that's ambiguous. Because law of sines only works for sure if it's angle, side, or angle, side, angle. So in this case, you could use law of sines, but it would be ambiguous case, and because you don't know whether this is an obtuse angle or an acute angle. You see?
Yeah.
Because if I end up solving it with law of sines, I might get that this is 80 degrees. But it also might be 100 degrees. You see? If I solved it with law of sines, so you'd have an ambiguous case if you did. So you have to use law of cosines again, okay, to find angle B. So if I found for angle C, I think I solved for angle C. So I'd use law of cosines again for angle C, and I get angle C is equal to, and the inverse cosine, and I'm not going to do the whole thing, of A squared, right? 5 squared plus 8 squared minus 7 squared divided by 2 times 5 times 8. And if I did that, I get that angle C is about 60 degrees. Okay? So angle C is approximately 60 degrees. And then I can just subtract from 180, and I find out that this angle is like, what does it come out to be? 81.8. This angle ends up being 81.8 degrees. Okay? So if you have just one angle and two sides, like a side angle side, you have to use law of cosines to find the other angle, because unless this angle that you find was obtuse to begin with. You understand that? Because if this angle is obtuse, then how many obtuse angles can I have in a triangle?
Only one.
I can only have one, and law of sines will give you see.
Yeah.
So if this came out to be like 100 degrees, then yes, I could use the law of sines, okay?
Awesome.
But because you can only have one triangle. But
So
you get that?
yeah,
Yes.
if we solve for B first and we found that that was the obtuse
Yeah, but
angle, then
yeah.
can we use
Yeah,
law of sines for the
yeah,
other ones?
yeah.
Okay.
But still, you got to be careful because
Yeah.
this isn't obtuse either, right?
Oh
So,
yeah, yeah.
If it were 91 degrees, then you could use law, right? Yeah, that's what I was thinking. Bigger than 80, it's obtuse. Okay, so let's do one where you're trying to find where you're given one angle on a side. Okay, so solve the triangle. Solve the triangle where A is C is 111 degrees. C equals 111 degrees. Little a is 27, and little b is 18. If it helps you, you can draw a picture. What happened? If it helps you, you can draw a picture, but you don't have to. Where's my Freehand shape. Here we go. We'll draw a picture. Anyway, I know that one angle is 111 degrees. Let's see if this works. Ooh, nice triangle. So let's call this your 111 degree angle. Let's call this side, and it doesn't really matter if this is angle C, then side A and B have to be the two sides surrounding that angle, right? So we'll call this little c, we'll call this big B, and we'll call this big A. And again, it doesn't matter which one you call A and B, but they can't be C. So now I'm going to use the law of cosines, the other one, that the other formula, c squared equals a squared plus b squared, so that's 18 squared plus 27 squared minus 2 times 18 times 27 times the cosine of 111, right? And notice that this is an obtuse angle, so this quantity is going to end up being a positive number, right? Because it's cosine of 111 is a negative number, right? So it's going to be a negative negative, so you're going to end up adding something to this side of the equation. Be careful though, do not do this. This is what people always do. They say, okay, I'm going to squish all this stuff together, and then I'm going to multiply by cosine of 111, and then they get the wrong answer. Because you're following the wrong order of operations. You understand that? Because it goes multiply and divide before you add and subtract, right? Please excuse my dear Aunt Sally. So if you did this, you would get the wrong answer. So don't do that, got it? So what you have to do is just do it all. You go multiply this together and then subtract it from this. Or if you stick it all into your calculator in one chunk, your calculator could figure it out, I think, for the most part. But if you get something that looks really weird, that doesn't look like it would be, like this side should be the biggest side of this triangle, right? Because it's opposite the biggest angle. And so if you do this, you get c squared is like 1401.3 or something like that. And so c comes out to be about equal to, c is equal to the square root of 1401.3, which is about equal to 37.4, which makes sense, right? Because it's bigger than those other two sides. Then could I use law of sines to find angle A and B? Yeah, then I could use law of sines because I know this is obtuse, and then I could use law of sines to finish it up. Okay? Need a minute to write that down, or are we ready to move on to the next problem? Don't do that eraser thing. That's okay. That's an. Is that the eraser thing?
Yeah.
Yeah, I knew that. I know that's a familiar noise. I know that sound. That's the way to drive teachers crazy. Okay, look at that beautiful picture up there. Now I have a word bearing problem for you. Chapter 6. Bearing problem. Where is it? Here it is. Where is it? Come on, buddy. You can do it. There it is. Law of cosine bearing problem. So a port is 50 miles due north of a lighthouse. So here's your lighthouse. Where's your lighthouse? Lighthouse. Let's draw lighthouse. Watch me draw a lighthouse. Here it is. Lighthouse. Lighthouses usually have stripes on them.
We need to add a light.
A light. Okay. What does that look like? Kind of like
Just
this.
big light bulb.
Big light bulb. There you go. And anyway, here's the port. Here's the port, and here it's just a dot. Okay. And I'm not a very good artist. So.
I think it's good.
Thanks, Frank. You get an A. All right. So a port is 50 miles due north of a lighthouse, and so here's the port straight up there, and that's going to be 50. Okay. And then a ship is 30 miles away from the lighthouse at a bearing of north 37 degrees east. So that means north, 37 degrees east. So maybe it's like over here somewhere, and here's my ship. Let's see, can I draw a ship? I can draw a ship. There it is. Queen Mary. There it is. And this angle here is 37 degrees. That's what that means. And here's this point, and that's 30 miles. And then what they want to know is what is the distance from here to here. Could you do that? Yes. Just use the law of cosines to find x, right? So we'll call that. And again, it's kind of nice to not think about the a squared, b squared. I'm just going to write this equation. X squared equals the two sides surrounding the angle, 50 squared plus 30 squared, minus 2 times 50 times 30 times the cosine of the angle in between, which is 37. Okay? So I don't even think about which is A, which is B, which is C. I just think about which are the sides around that angle. Okay? That's easy enough? I'm not going to solve that. You can. Okay, and the last thing is called Heron's formula. That's kind of a cool formula. Heron's formula, and they derived this from the law of cosines, and I think the law of sines combined. Or maybe trig. You can look in the book to see how they derive it. But it's used to find areas of oblique triangles when given just 3 sides. So say, and Heron's formula says this, that the area is equal to the square root of, has anyone ever seen Heron's formula? They do have it in the geometry book, but some teachers, I usually skip it. S minus A times S minus B times S minus C, where A, B, and C are the sides of the triangle, and S is equal to A plus B plus C divided by 2. In other words, it's the perimeter divided by 2. So for example, find the area given sides, let's make up some sides, 8, 11, and let's make it
13.
And 13. That works. Okay? So all you have to do is find S. S is equal to 8 plus 11 plus 13 divided by 2. How much is that? 24. Is that 16? 16, right? Okay? And then you just plug into the formula. Area is equal to the square root of 16 times 16 minus side A. So you call one side A. So what's that? What's S minus A? 8, right? 16 minus 8. Then it goes 16 minus 11. What's that? 5. And 16 minus 13? 3. And then you multiply all that junk together and you get the square root of some big number. 40, I don't know what that is. I'm going to do that in my head. 1920. Is that right?
Yes.
Oh!
Don't you have the notes there?
No! We just came up with that number. I'm like the math magic guy. Okay, you know how I did that in my head so fast?
What's the square root of it?
I don't know. So how did I do that? Because I said it's 40, and I know that 4 times 16 is 64. So I did, and I added a 0, so I said 640, and then I multiplied 64 times 3, and I got 192, and I added a 0. Pretty good, huh? Math tricks. Dumb math. But anyway, and if you take the square root of that, okay, you get that the area is about equal to what?
43.8.
Thank you. 43.2. And that's all there is to Heron's formula. It's kind of cool because all you need is 3 sides. You don't have to know the height or anything. You just plug it in, and then you've got the area of a triangle. So, it's nice. What is it?
It's 43.8.
33.8?
43.8.
Oh, let's get picky here. So there you go, 43.8. All right, but otherwise you'd have to like take one of the sides and then find the height of the triangle or something like that, or find an angle. And it's this kind of a thing. Does everyone see where that came from? Okay. Yes, Max?
S minus, oh,
8 plus 11 plus 13 divided by 2. Okay. And that's all she wrote. And there's some homework on the school website, or my Schoology. You have 15, 18 minutes or something like that. You can work. I'm going to stop and stop my cutting edge video and work.